Hey guys, today we are going to continue on with our trigonometry unit, and we are going to learn how to solve a side in a right triangle. Okay, so open up to 10.3, right triangle trig, solve for a side. If you remember our saying from last time, SOHCAHTOA, this is how we remember that the sine is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse, and the tangent is opposite over adjacent. So we're going to label our triangle just like we did last time. Remember to identify the 90-degree angle. Take a walk through the middle of the triangle, and that puts you at the hypotenuse. So I'm going to put an H here on the 7. And then I'm going to label the X because the other side doesn't have a variable or anything, so I'm not going to worry about that. So X is a cross or opposite of the angle 54.7. So this is the opposite side. Okay, so using these two sides, the X and the 7, this is the opposite side of angle 54.7 and the hypotenuse of the triangle. So looking up here at my SOHCAHTOA, I see the O and the H, so this goes with the S, which stands for sine. So I'm going to write down the sine, and then angle always goes after the sine, cosine, or tangent. So the sine of my angle, 54.7 degrees, is equal to the opposite side, so X is going to go on top, over the hypotenuse, which is 7, and that's going to go on the bottom. Okay, so I'm going to solve this for X by getting rid of the 7 in the denominator. We're going to multiply the 7 over here on this side and get rid of that 7. So X equals 7 times the sine of 54.7. Now I'm going to enter that in the calculator. So in your calculator, push the button mode, it's right next to second. Go down and make sure you are in degree. So go over, use the arrow, go over to degree, hit enter. Okay, you want to make sure you're in degree mode before you do this. So I'm going to just type exactly what it says. 7 times the sine of 54.7, and it knows it's degrees. I'm going to round to the 1 decimal place, so 5.7. So in this one, X would be 5.7. Okay, so if the number is on the bottom, we multiply. Let's do the next one. So I'm going to label the X and the 5. This is my angle 60. This 5 is not opposite of it, so it would be adjacent. And then here's my 90. Walk through the middle, I get the hypotenuse and the adjacent side. So looking at this, it's the C, which stands for cosine, adjacent over hypotenuse. Cosine of 60 degrees is equal to the adjacent side over the hypotenuse. Okay, I want you to notice that X is in the bottom here, where over here we had a 7 in the bottom and X on top. So you have to look very carefully at your ratio right here. If X is in the bottom, it's different than X in the top, okay? If X is in the top, I just have to multiply this 7 over. If X is in the bottom, we have to do some math. Okay, I'm going to do the math and then I'm going to tell you a shortcut. So I'm going to times by X, just like we did on the other one. So we get X times the cosine of 60 equals 5. And then I need to get X by itself, so I divide by the cosine of 60. So X equals 5 divided by the cosine of 60. Okay, so going back to our first problem, or our first equation that we had the cosine of 60 equals 5 over X. So the shortcut here is if X is in the bottom, I can circle this and then switch them places. So x equals 5 over the cosine of 60. So that's kind of a shortcut. You can go through the steps and get the same thing, or you can do the shortcut, okay? So in your notes, you probably want to write, if x is in the bottom, switch places. Okay, and you'll probably have to look back at that note sheet to see how to do that. Go back to our calculator. 5 divided by the cosine of 60, close the parenthesis, and we get 10. So the answer here, x equals 10. Okay, we have 2 more problems. Number 3. So this is find B if C is 4 and the measure of angle B is 44. So we always are going to draw our triangle, our right triangle, okay? So that's going to be on example 3 and example 4. We're drawing a right triangle. Label the right angle as C, go across from it and call that little c. This corner is going to be A, across from it's little a. This corner is going to be B, and across from it is little b. So the A and the B could switch places and it wouldn't matter, as long as C is in the right spot. Okay, so we're finding B, so this is our x, right? And we know little c is 4, so we know this is 4. And then I know angle B is 44 degrees. All right, so using our ratios, from this is the 44, x would be opposite, and the 4 is hypotenuse. I don't need to know what A is because it didn't ask me for it, and it wasn't involved in anything it gave me. Okay, so using opposite and hypotenuse, I know I'm going to do the sine. That's our so, right? So the sine of 44 equals opposite over hypotenuse. And in this case, we're going to multiply by 4. So we're just going to put that in the calculator. Come a little lower. So 4 times the sine of 44. And we get 2.77. Now, I want you to see that this is a 7, and then that second number is a 7. So this 7 is actually going to turn into an 8 with rounding, okay? So x equals 2.8. Okay? All right, we have one more. So if A, we're finding A, so put an X for A, and then little b is 4, and the measure of B is 22.7 degrees. So I'm going to label these two sides. So this is opposite, this is adjacent. So that's TOA. Okay, so this is the tangent of 22.7 degrees equals opposite side, which is 4, over adjacent side, which is x. Okay, remember if x is in the bottom, I switch places. Okay, so I'm going to switch these two places. So x equals 4 divided by the tangent of 22.7. Type that in the calculator. And again, our 5 is going to round up because the number next to it is greater than 5. So x equals 9.6. Okay, so that's how you solve for a side on a right triangle. Now we have one question on example 5 that's a story problem or a real world problem, okay? So it's saying a 9-meter ladder makes an angle of 55. So I can't really see this, it's kind of small. So I'm going to write this again and I'm going to draw. This is my ladder. It's leaning on the building, okay? The ladder is 9 meters This angle is 55 degrees, and then this is x. Okay, so it says, how far is the bottom of the ladder from the base of the building? So here's the base of the building, and I want to know the bottom of the ladder. So part A is asking for x. So this is the same as the problem we just did. So this 55, this is the hypotenuse, and this is adjacent. So we're using ca, which is the cosine. So cosine 55 degrees equals adjacent over hypotenuse. So x equals 9 times the cosine of 55. And we put that in the calculator. Okay, this one is also going to round up. Since 6 is bigger than the 5, it's halfway. So x equals 5.2. And now this time we're talking about a ladder and a house and distances. So let's say meters. Okay, so how far is the bottom of the ladder from the base of the building? It's 5.2 meters. So this is part A. All right, part B, how far up the building does the ladder reach? So here's where the ladder hits the building, right? And here's the bottom of the building. So it wants to know, what is this distance? Let's call it y. So I noticed that I'm not using x anymore. So I don't want the adjacent side for this problem. I'm now using the opposite side. So I'm going to switch this time, and now we're going to do the O and the H, which is the sine. So the sine of 55 equals the opposite over hypotenuse. So 9 times the sine of 55. 7.4. So y equals 7.4 meters. That's part B. So when you do these story problems, you want to make sure it makes sense in real life, right? You're not going to have a negative distance in real life. So you want to just kind of put back into the problem and say the building reaches, or the ladder is 7.4 meters up the building. That would make sense. Or the bottom of the ladder is 5.2 meters from the base of the building. That makes sense. If I got a negative number, I would know I probably entered